One of the ways that we can compare the strength of an acid is with degree of ionization, or sometimes it'll be expressed as a percent ionization. For strong acids and bases, this means that it is 100% ionized. So this is maybe the same language that we've been using to talk about strong acids and strong bases. We may have said dissociated. Ionized would be the same thing, but if it is strong, that means 100% split up or 100% reacted in water. For weak acids and bases, if we wanted to communicate a percent or degree of ionization, what we're looking at is the equilibrium concentrations of either H plus or BH plus if you have a base divided by the initial concentrations of the acid and the base. So how much of the free ions do we have compared to the amount that we started with? Multiply by 100 if you would like this as a percentage. Now, I have an example, and the example involves getting some information out of a pH, which we have looked at already, but it's possible that you could be asked about this with other information. As long as you know how to get to the concentration of the ionized substance at equilibrium and you know the initial concentration, then you're good to go. So the example says 0.2 molar HNO2 has a pH of 2.02. So that's a weak acid. This is nitrous acid. And okay, that's all we're given for percent ionization. But we know the initial concentration, which is the 0.2. We can use the pH to find the H plus concentration at equilibrium. Now, this works even though it's a weak acid because pH depends on how much H plus is in solution. It's a measure of that. And so what we'll really often do is just use a pH meter to get the pH of a solution and then use that piece of data to get other information. So the H plus at equilibrium, right? Double check your math here, but you should be able to do this with an anti-log and find that the H plus at equilibrium is 9.6 times 10 to the minus 3 molar. That number divided by 0.2 and then multiplied by 100 gives 4.8% ionized.